Okay, Chapter 2, Conception and Genetics. Oh, there we go. Yes, and it's feathers today. Conception takes place when a single spermatozoa combines with a single ova in a woman's fallopian tube. It has to be the fallopian tube, and this is the path it has to take. This is the vagina here. This is the uterus. This is the cervix right there. The cervix is usually closed, and the cervix only opens up during menstruation, and it opens up during when the lady is ovulating. Otherwise, it is closed. There's nothing that can get into this area. So what the sperm has to do, it starts here, goes into the uterus, then has to make its way to the correct fallopian tube. Not all fallopian tube, or not. There are two of them, of course, and it doesn't happen very often. But sometimes both fallopian tubes, of course, will have an egg, but they don't. Normally, it's just one, and they have to make their way up the right fallopian tube and impregnate the ova. And the sperm has to be perfect, otherwise it's not going to make it all the way up here. It has to swim all the way from here up to here. The woman is born with all the ova that she will ever have, about 400,000 of them. In most months, of course, a woman will only have one viable ova available for fertilization. The man will ejaculate as many as 1 billion sperm in any one ejaculation, depending on his sperm count and the volume of his ejaculation. The longer it has been since he has had sex, the more ejaculate that he will have. Each milliliter, how many mils are in a teaspoon? 5, I think. Each each mill will have as many as 350 million, uh, 350 million sperm in it. And in order to make all those sperm, he has to pump them out really fast. And that's exactly what's going on as far as his testes are concerned. It can be pumping out as many, and of course it changes throughout the day. But when he is at his peak of producing sperm, he can produce as many as 30,000 per second of sperm, and because he needs all those. As you can see, most of the sperm don't make it into the uterus, and even the ones that make it into the uterus, half of them are going to go up to the wrong fallopian tube. So it can take 1 billion sperm to impregnate somebody, as strange as that may seem. Hundreds of millions of sperm are produced in the testicles of most males every day, so potentially he could impregnate somebody every day. He could potentially impregnate more than one person in a select day. Each male ejaculation in the female vagina deposits hundreds of millions of sperms. However, unless the woman is ovulating, the cervical opening is closed and won't allow the sperm to enter the uterus. Since the sperm cannot enter the uterus, they cannot find their way to the fallopian tubes. When ovulation occurs, the mucoid plug that protects the cervix becomes more liquid, allowing the sperm to enter the uterus. And of course, there's a reason that this has to do with protection from the environment, bacteria, viruses. You certainly don't want anything to get into the uterus or the fallopian tubes. It can scar them. It can damage them. So the female has some really interesting protection, and one of them is that in her reproductive area, the mucoid plug will protect her from anything getting up into there. The other thing is that a female's reproductive area is extremely is fairly acidic, and that protects her from most bacteria and viruses. It's just too acidic. So in order to neutralize the acidic environment of the female's reproductive area, the male's semen is very alkaline. And since it's so alkaline, Since it's so alkaline, it neutralizes the acidity. Now, the interesting thing is that a male who is not producing alkaline, a properly alkaline semen will not be able to reproduce because the female's acidic vagina or the reproductive area will not be neutralized, and it will kill the sperm. Fertilization is most likely to occur if intercourse takes place on the day of ovulation or the 5 days before ovulation. And this is why when a woman is having a hard time getting pregnant, she will track her ovulation so that they can be sure to have sex at the right time so that she might potentially get pregnant. While almost all births are of one child, sometimes women will give birth to 2 or even 3 infants. There are 2 ways a woman can have more than one child. In 2/3 of all twin births, a woman will produce more than one ova, usually from each fallopian tube, and each ova is fertilized and forms a zygote, another name for a fertilized ova. These twins would be referred to as dizygotic twins because there are 2 zygotes, 2 dizygotic, di meaning 2 and zygotic meaning the fertilized ova. These are commonly known as fraternal twins, dizygotic or fraternal twins. Sometimes a single zygote will split and form 2 identical zygotes. These twins are referred to as monozygotic twins and would be commonly referred to as identical twins because they come from one zygote. Now, for the longest time, we thought they had identical DNA, and now we have, after research in Denmark, they discovered that this isn't true at all, that they don't have identical DNA. So you can tell the difference between the 2 of them. A story. I used to work in a pediatrics clinic in Washington, D.C., or outside of Washington, Vienna, Virginia. We had a mother that had 3 children. She had triplets, and 2 of her triplets were identical twins, and the third triplet, and they were male, and then her other child was a female, and she was the runt. She was born as if she were premature, which seems a little odd. The other 2 were just big as trucks, but she was born small for her size. She was in the hospital for over a month before she could go home. It's really a fascinating situation because the 2 male fetuses took almost all the nutrients, and the little girl didn't have very much at all. But she was produced from one ova, and the twins were produced they were monozygotic twins. It's really kind of fascinating that they had a dizygotic birth and a monozygotic birth at the same time. Really fascinating. Twin birth rates in the United States are about 3.3% of all births are twin births. The group that produces the most twin births are the Caucasians, the white population, has 3.8%. The African American population, 3.7%, and the Hispanic population has the lowest at 2.2%. These are dizygotic twins, as you can see. This is the Bush twins, George W. Bush. She is she's on television, I think, in the morning. I don't know what this one's doing. Anyway, one of them has blonde hair, the other has brown hair. One has a thin face and one has a round face. One looks like George and the other looks like, I can't remember what his wife's name is. These are a pair of twins from the Netherlands. I'm going to show you a picture of them, another picture of them in just a minute. One was white and the other was I don't think you could call her, I don't think her father or mother are black. But as you can see, one is dark and one is relatively light complexion. There's the mother and father. Little girl looks just like the dad. This little girl looks just like the dad. And of course she is, they both had white ancestry. They also both had, African ancestry, so I guess you could call her, both of them black, I guess, if you like. Anyway, there's the two girls. This is them later. The father wasn't with them anymore. And as you can see, one's dark and one's light. They all have curly hair, as interesting as that is. Anyway, there you go. Those are a set of twins in the Netherlands. I haven't seen them lately. I'm sure these are kind of old pictures. They're about 4 or 5 years old. Not the same set of twins. They are the Aylmer twins from London. The other twins were from the Netherlands. And as you can see, they are dizygotic twins. Obviously, they're dizygotic. Monozygotic twins, they look just almost identical. Or they are identical, actually. Anyway. Monozygotic twins, identical twins, and dizygotic twins. It is estimated that between 8% and 17% of U.S. couples are unable to conceive. They have a problem with fertility. They experience infertility. The most common cause of infertility in men is a low sperm count, and it's really kind of odd. I was a medical laboratory technician, and one of the things that we worked with was sperm counts. We did sperm counts. And when I first started in the lab in the early 1970s, normal sperm count was between 250 and 450 million sperm per mil. It's gone down, and we know it's gone down. It's gone down worldwide, and nobody is quite sure why. Anything below 40 million sperm per mil, they assume that the sperm count is too low for the individual to be able to impregnate anyone. As interesting as that is, but the sperm count used to be much higher. They used to say it was 100 million. Now they're saying the norm was between 100 million and 450 million when I first started, and now, as you can see, it's between 40 and 300 million. Rare to see anybody over 300 million now, but we used to see them all the time. And you may ask yourself, why in the world did you do so many sperm counts? And the answer is that I was in the Air Force, and sometimes we had pilots that had a difficult time impregnating their wives. And the reason they had, and as we eventually figured out, the reason they had a difficult time was because they were pulling so many G's. It really changes situations. It lowered their sperm count, as interesting as that was. So what they would do if they wanted to, if this were an issue for them, what they would do is stop flying for a while, and then they would have children. And the other thing was, it was really kind of interesting. They had more female children than they had male children. That was the other thing. Another problem that a man may have is sperm that are abnormally shaped and thus don't swim adequately to reach the ova. Far more rare occurrences that there are genetic bases for the infertility. One way that one substance that causes abnormal shaped sperm is marijuana. It's quite notorious for creating abnormally formed sperm. This is what sperm look like under the microscope. This one's this is the head, this is the tail, of course. I mean, they look like tadpoles. Right behind the head is a power pack. That's right there, as you can see. There's a power pack. If it has no power pack, it can't swim. It can't move its tail, as weird as that is. Anyway, this is what they look like. And you can imagine if somebody's got 450 million sperm per mil, and you're looking at a droplet of them, they're just all over the place. And of course, you've got to identify the abnormal forms. That's the weird part. And this is what a normal one looks like. As you can see, the power pack, and there's the head, and it has to be this shape. If it's any larger than that, then there's a problem. you would call this an abnormal form because it's much too large. This one has the head's too small. Sometimes you'll see tails without heads. Sometimes you'll see heads without tails. Sometimes you see two heads on the same tail, or two tails on the same head. The problem with these guys is, especially the two-tailed ones, they swim around in circles and they don't go anywhere. And of course, they have to go straight. They have to swim as straight as they possibly can. And you see all kinds of odd, abnormal forms. And with marijuana, as marijuana becomes more and more popular, of course, it may be that the fertility rate in the United States lowers. It's not uncommon for well, there are states that have legalized marijuana, and of course, not everybody's smoking marijuana, but this can be a problem. Caffeine can potentially cause some degree of problem. Tobacco does as well. Too much alcohol. There's just about any of these toxins that you put in your system can cause abnormal forms. Reproductive problems with women often include problems with producing or transporting ova. Abnormal ova can also be a cause. Excessively thick mucus covering the cervix may also be a problem. Problems with the health of the uterine wall will prevent implantation. For women over 30, the problem may be deterioration of the quality of the ova. However, the most common problem preventing women from becoming pregnant is blockage of the fallopian tubes. I had a girlfriend one time who wanted to get pregnant very, very badly, and she never could. Of course, she didn't blame herself. She blamed everybody, anybody who was trying to get her pregnant. So eventually what happened, when she was in Holland, she was stationed in Holland, and they looked at her fallopian tubes through her belly button. It's called a histocypingiogram. And they would look at her fallopian tubes. And what they discovered was that her fallopian tubes she was born with her fallopian tubes stuck to her rectum, to her colon. So there was this unnatural kink in there, and the ova just couldn't get out. Luckily, the ova weren't getting impregnated because it was blocking it. So what they did, they went in and they fixed that so that it was straight. But the problem was they couldn't fix it so it was perfect. And so the first time she got pregnant, she had an ectopic pregnancy and blew out one of her fallopian tubes. Now she only had one. She was deathly afraid to have sex with anybody. It was really kind of a sad, curious situation. Eventually what happened was that she was artificially inseminated. They harvested her ova and impregnated them in the test tube. And then they replanted them. She had a set of twins. This was way long after she was no longer my girlfriend. Anyway, the other problem can be, and of course the scarring, the odd problems that you can have in your fallopian tubes. Sexually transmitted infections can cause the problems, especially gonorrhea and chlamydia can cause scarring in the fallopian tubes. Heredity is transmitted through a substance known as deoxyribonucleic acid, or DNA, the famous DNA. An individual's DNA is a combination of their mother's genes, of course, and their father's genes. DNA is made up of a combination of 4 amino acids: adenine, thymine, cytosine, and guanine. An individual's genetic code is a series of 3 billion pairs of these 4 amino acids. Now here's the bizarre part. Okay, so the largest unit of the hereditary structure is a chromosome. There are 23 pairs of chromosomes, a set of 23 from the sperm and a set of 23 from the ova, for a total of 46 chromosomes. Chromosomes are constructed of genes, about 30,000 in each cell. One cell will contain a full strand of DNA So each gene will be a segment of DNA. 99.9% of the genes in any human's body are identical to all other humans. So when we're checking people's DNA, we really don't have to look at the whole structure. We only have to look at 0.1% of that structure to see the difference between this person and that person. And this is the reason that DNA is. It took a long time to figure this out, but eventually we did. Um, as a matter of fact, we have 98% of our genes are identical to a chimpanzee, as weird as that it is, but it's the 2%, of course, that makes us different. They also have 52 chromosomes, if I'm not mistaken. So people think, well, why don't you produce all these strange offspring? Why can't humans breed with gorillas or orangutans or chimpanzees? And the answer is because the DNA doesn't match up, and it's just impossible. It will not work. These genes are known as monomorphic genes. They have one structure, the 99.9%. The 0.1% are different for each individual. These genes are known as polymorphic genes, or mini structures. The chromosome that determines if an infant is going to be a male or a female is the 23rd chromosome, or sex chromosome. All cells in the body carry 46 chromosomes, except an individual's ova or sperm. Each ova and sperm have 23 chromosomes. And when they get together, they deliver half their genetic material from their father and half from the mother. All ova are female or carry an X chromosome, so if it was up to females, all of their offspring would be female. The male determines whether the offspring will be male or female when a male Y or female X sperm breaks through the wall or is drawn into the ova, as some people think. And this is about right. And I'm going to show you a picture of a electron microscope picture of an X and Y chromosome. But the Y, you can see the X chromosome is much larger than the Y chromosome. And this causes all kinds of interesting problems. So we'll get into that in just a second. I have a brother-in-law who he and my sister reproduced 4 times, and all 4 of them were girls. And of course, he blamed her because, well, he's a macho man, and he thought that it was her fault that she was producing, that all of her babies were female. But the reality is, it was his fault, and so he can just shut up, which never is going to happen anyway. And there you go. This is a real picture of an electron microscopic picture of an X and Y chromosome. The male and the female chromosomes are actually shaped like an X and a Y, just as you see. And because of this, several abnormal genes found on the X chromosome will not be canceled out by the genes on the missing arm of the Y chromosome. These are known as sex-linked diseases and include hemophilia, color blindness, and male pattern baldness. Queen Victoria had 9 children, I believe. Queen Victoria, there was a hemophilia was on her chromosome, or was on her X chromosome. And because of that, of her 9 children, I think half of the boys had hemophilia, and half of them didn't. But that spread throughout the royal families of Europe and Russia, as a matter of fact. Let's see, who was it? It was the last Tsar, or the last Tsarevich, the offspring of the Tsar. He had hemophilia, and of course that was a really serious problem. And here we go, X and Y chromosomes. This is a really very good picture because in this picture it looks like the Y chromosome is about the same size. But the reality is, as you can see, this is the X chromosome, the Y chromosome. Y chromosome is much smaller. Now the problem is, if there's a flaw on the X chromosome, the Y chromosome won't cancel it out. Now with the little girls, of course, since the male X chromosome is exactly the same size, it will cancel it out. But if the child is a boy, is a male, then the Y chromosome is not large enough to cancel it out. A lot of dominant and recessive inheritance. Dark hair is dominant over blonde hair. Normal hair is dominant over male pattern baldness. Curly hair is dominant over straight hair. Non-red hair is dominant over red hair. Widow's peak hairline, which is what I have because I'm white, is dominant over a rounded hairline like most natives have. Facial dimples are dominant over no dimples. Normal hearing is dominant over some form of deafness. Normal vision is normal over nearsightedness. Farsightedness is normal over normal vision. Normal vision is dominant over congenital eye cataracts. Normal color vision is dominant over red-green blindness. And pigmented skin is dominant over albinism. Albinism is where you have no pigment in your skin. Double jointedness is dominant over normal joints, as strange as that may seem. Broad lips are dominant over thin lips. Arched Roman nose is dominant over a straight nose. Extra fingers and toes are dominant over 5 fingers and toes, as strange as that may seem. I had a friend who all of his children had 6 fingers. They had an extra finger coming out of the palm of their hand, and they had to have that cut off at birth. Otherwise, it would have caused all kinds of interesting problems. It was fairly non-functional. There was no joint. It was just kind of stuck there. It's kind of weird. Short fingers and toes are dominant over normal length fingers. Immunity to poison ivy is dominant over sensitivity to poison ivy. There were 6 of us in my family, and one of us was sensitive to poison ivy. It was my older sister. Well, both my sisters are older than I am, but it was my oldest sister, I guess that's what I should say. Type A blood is dominant over type O blood. Type B blood is dominant over type O blood. Rh positive blood is dominant over Rh negative blood. Now this can be a problem, as we're going to talk about type A blood and COVID-19 in just a second. Oh, here we go. We're going to talk about it right now. This is from Wikipedia. As you can see, O positive blood is the most popular blood among all the dominant, the most numerous people in the United States. Caucasian, 37%. African Americans, 47% have O positive. Hispanics, 53%, and Asians, 39%. O negative is there's a lot of O negative Caucasians. This has no antibodies. Type O blood. O just means there's no antibodies, and the positive is an antibody. The Rh factor is an antibody. So O positive has no antibodies. This is a universal donor. AB positive is universal acceptor. As you can see, not very many. Now there is a problem. 33% of Caucasians have A blood. No, it's 40% have A blood. Among African Americans, it's 26%. Among Hispanics, it's 31%. Now, A blood, as we have discovered with COVID-19, A blood, people tend to overreact. When they have an infection, they tend to overreact. So if somebody catches a cold, if they catch a normal rhinitis, which is a common cold, whereas somebody with O blood, they'll have the cold for 5 to 7 days. Somebody with A blood, they'll have symptoms because they overreact to the infection. They will have the cold for 7 to 10 days. So it's an overreaction. And this is what we've discovered with COVID. So people with type A blood seem to be overreacting to the fact that they have the COVID. These are the individuals that are more likely to die, to be put on ventilators and die from COVID-19 because they're overreacting to the infection, whereas people with O blood are more likely to survive. People with B blood are more likely to survive, and AB blood is likely to survive. It's these guys right here with A positive and A negative blood who are overreacting to the COVID-19 infections. Each parent contributes half of the genetic material, and each will match up to determine hair color, eye color, etc. Each parent contributes half of the material for each characteristic. Thus, for each characteristic, an individual will receive two alleles. When both parents contribute the same allele, such as two blue-eyed alleles, the characteristic is said to be homozygous. If the two characteristics are different, then they are said to be heterozygous. In a situation where there are heterozygous traits, some characteristics will be dominant and some will be recessive, while still others will be blended. Skin color tends to be blended. Eye color is dominant or recessive. My mother had brown eyes and my father had blue eyes. Of the children, and as it turned out, we'll talk about that in just a second. But I have two brothers, and I have blue eyes, and I have a brother and a sister with blue eyes, and there are three of us have brown eyes. My mother had brown eyes, so she must have been heterozygous brown. In other words, she also had a blue trait. Her genotype was blue because she was able to reproduce, and her ova, in 3 cases, her ova had the blue-eyed trait. And my father, of course, because he's blue-eyed, he always the gene that he gave was always a blue-eyed gene. Now, as interesting as that is, I said I had blue eyes. I married a woman with brown eyes, and we reproduced twice, and both of our children have brown eyes. So that tells you that potentially, and we don't know, we could have reproduced a dozen more times, and potentially one of them may have turned out with blue eyes, and that would have meant she was heterozygous. But I have a feeling, since her mother was brown-eyed and her father was brown-eyed, that she was brown-eyed homozygous. Okay, as weird as that sounds. When looking at genetic structures, it is easy to see which traits are dominant. The observable traits that are created from dominant inheritance is known as an individual's phenotype. What we can see is the phenotype. The hidden or possibly recessive matching structure is known as the genotype. So that's what we were looking at with my mother. We didn't before they got married, she could have been homozygous brown, have homozygous brown eyes, so that all of her ova would have been brown-eyed ova, and she would not have been able to produce blue-eyed children. But her genotype was brown-blue, and because of that, she was able to produce blue-eyed children, as I am a proof of that. So her genotype was brown-blue, and her phenotype, of course, was brown because that's what we saw. And that's the way genotypes and phenotypes work. With the thousands of genes and billions of combinations of amino acid that must go together, it may seem surprising that any normal children are born at all. But the reality is that any genetic flaw or outrageous abnormality that will not sustain life usually terminates long before the infant is due. Usually before the first trimester, very often before the woman even realizes she's pregnant. She will, the fetus will, or the zygote will not implant, the zygote will not survive. And this may be one of the reasons why a woman is late, and then all of a sudden she has her period. Lots of different reasons for that. It doesn't have to be just because she's late in her period. Stress can cause a prolonged or a delay in your period. There's lots of different reasons for all of these things, but that's also a possibility that they have produced a zygote that isn't viable. However, there are some instances of sex-linked inheritances and mutations that produce offspring that may have some serious problems that will eventually lead to death. And these are the problems. These are some of the birth defects from chromosomal abnormalities. Antitrypsin deficiency causes liver problems. Alpha thalassemia is a severe anemia which causes infant death. Beta thalassemia is severe anemia causing teen death. Cystic fibrosis, too much mucus, causing lots of horrible problems. Duchenne's muscular dystrophy is a male degenerative disease. Hemophilia is a male bleeding problem. Anencephaly is lacking all brain tissue. This, of course, causes infant death. Spina bifida is incompletely closed spinal column. Phenylketonuria, or PKU, is digestion failure causing intellectual disability. Polycystic kidney disease, serious kidney problems causing death. Sickle cell anemia is deformed red cells in Africans. And Tay-Sachs disease is a degenerative disease of nerve cells in Ashkenazi Jews. The Jewish population is really kind of interesting. They started in the Middle East, and if you've read the Bible, you know that they had lots and lots of problems. They got captured and they got enslaved in Egypt. They had what they called the Jewish diaspora, where they couldn't go back to their homeland, so they spread throughout the world. Well, some of them went to, one group went to, there's a lost tribe of Israel, as curious as that is, but we're not exactly sure where those people went. But one group went to Eastern Europe, one group went to Spain and North Africa. The ones who went to Spain and North Africa were referred to as the Sephardic Jews, and the ones that went to Eastern Europe, Russia and Eastern Europe, were called the Ashkenazi Jews. And of course, Jewish people can only marry other Jewish people, and of course the ones in there was a mutation, and it caused Tay-Sachs disease among the people in Eastern Europe, and they had this problem, this Tay-Sachs disease. 1 out of every 12 African Americans carries the sickle cell anemia trait. 7 out of every 10 African Americans, 70%, will have a milk intolerance. This is a lactose intolerance as adults. So if you're ever around African Americans, potentially they won't want cheese or ice cream or whatever. No cheeseburgers for them. 1 out of every 10 African American males has a hereditary predisposition to develop hemolytic anemia after taking sulfa or other drugs. This is really kind of curious. The way we discovered this was that they used sulfa drugs during World War II. But strangely enough, the military segregated their units, and they wouldn't allow African Americans in combat units until the very end of the war. Well, some things happened, and of course the sulfa drugs weren't always being used, and so we didn't discover anything. Then they integrated the combat units during the Korean War, and during the Korean War we discovered that there were select African Americans who had some really serious reactions to sulfa drugs. And the only way we discovered that was because of they were in combat, they were being wounded. We needed to give them antibiotics to keep them from becoming infected. And all we had were sulfa drugs. And we had sulfa and we had penicillin. But there are people that are allergic to penicillin as well. If you're allergic to eggs, you're allergic to penicillin. And that's how we discovered it. We treated them with sulfa drugs, and then they became anemic, and we either had to stop giving them sulfa drugs or we killed them. One out of every 50 African American females has a hereditary predisposition to develop hemolytic anemia after taking sulfa drugs or other drugs. That tells us, of course, since there are so many more males that have the problem than females, that it is sex linked. In other words, it's on the X chromosome of the mother. And if that is the case, then 1 out of 10 will have a problem with sulfa drugs. 1 in 25 whites also are carriers of the gene cystic fibrosis. 1 in 80 whites are carriers of phenylketonuria, PKU. It's almost not. It's relatively rare in other races, but it's not common. Of course, 1 out of 80 is not very many, but we see it in the white population. 1 out of every 100 Ashkenazi Jews are carriers of TaySachs disease, familial dysautonomia, and these people are Ashkenazi Jews. 1 out of every 10 Italian Americans and Greek Americans will carry genes for beta thalassemia. That's the anemia, adult anemia. And I can't remember which ones of these are Greeks and which are. I think these guys are Greeks and these guys are Italians, or vice versa. I don't know. 1 in 45 Armenian and Sephardic Jewish individuals are carriers of familial Mediterranean fever, Cooley's anemia. I found a case of this once upon a time. This lady is Armenian and this lady is a Sephardic Jew from Spain, or they started in Spain. Actually, the Sephardic Jews in Spain were kicked out of Spain. That's how Queen Isabella financed Columbus's trip to the New World. She stole all the money from the Jews she was kicking out. As weird as that is. Anyway, Cooley's anemia. I found some Cooley's anemia in an individual from Italy. He was of Italian descent, Italian and Armenian descent. Afrikaners, or white South Africans of Dutch and English extraction, have a 1 in 330 chance to have porphyria. Porphyria is a genetic abnormality where the individual is unable to process oxygen from the red blood cells in select organs or organ areas, especially the skin and the nervous system. Their skin sloughs off. It's a pretty ugly disease. Their skin sloughs off, and they slowly lose the ability to move because of the destruction of their nervous system. Almost 100% of Asians are unable to digest milk as adults. This is lactose intolerance. Almost 100% of American Indians are unable to digest milk as adults. Also lactose intolerant. These guys are from South America. I'm not sure why I put that in there. In most cases where there is an extra chromosome, the zygote would not survive due to severe abnormalities. However, when there is an extra sex chromosome or even a missing one, the individual will develop but have select sexual problems. Sometimes we see trisomy 23, XYY. The individual develops as a male. They are tall, male. They have a slightly lower IQ, and they have poor verbal skills. There's the triple X. This individual will be a female, and they will have menstrual irregularities and some degree of intellectual deficit. XXY, this is known as Klinefelter's syndrome. They will develop as a male. They will have few sexual characteristics because instead of an XY, they are an XXY. So they have few sexual characteristics and they have learning problems. XO is known as Turner syndrome. The individual tends to be a short, sterile female with incomplete development. Somebody with Turner syndrome, let's see, what is that lady's name? Helen Hunt. Not Helen maybe it's Helen Hunt. Anyway, if you watch NCIS Los Angeles, she's the leader, she's not a very tall woman. They can't reproduce, as interesting as that is, and they never develop sexual characteristics. As you can see, they only have one X chromosome instead of two. Fragile X is is a broken arm on the X chromosome, causing intellectual deficits that are more severe in males than in females, because their Y chromosome will not cancel it out even to a minor extent. In females, of course, it cancels it out to some extent. 3 other chromosomes of the 23 pairs can have an extra chromosome or trisomy. The most common case of extra chromosomes is trisomy 21, better known as Down syndrome. In Down syndrome, the individual may have mild to severe intellectual disability with various organ and physical malformations. The second most common trisomy is trisomy 13. In trisomy 13, the infant is born with multiple nervous system, organ, and facial malformations. 72% will die before their first year of age. Trisomy 18 is less common, but also results in more terminated pregnancies due to fetal death. In trisomy 18, the infant is born with severe nervous system, organ, and facial malformations. 90% die before they are 1 year of age. Now, you may think, how in the world do we know all of these things? We can do a DNA study by looking at geez, it was just in my brain and it just left. We can draw some of the fluid out of the uterus, out of the placenta, and we can do chromosomal studies on those individuals. We can do what's called an alpha-fetoprotein to find out if there is an excess amount of cerebrospinal fluid in the individual. If there's an excess amount of spinal fluid, then it will show up in the mother's blood. So this is something that we can do. We can do these tests on a woman to find out if the fetus has a chance of being abnormal. And sometimes they do them, and sometimes they don't. If it's a young person, they usually don't, because younger people don't have problems with their pregnancies, but older women do, and so they'll have all of these tests done to see if they have Down syndrome or to see if there's another problem. The older the ova, the more likely there can be a problem, as we're going to find out, I think. Researchers are discovering a great deal of information by studying groups of monozygotic twins. Interestingly, even when the twins come from the same zygote, in 1/3 of the cases, each embryo will create its own chorionic sac. By comparing these twins with dizygotic twins and monozygotic twins that were separated at birth, researchers are getting a new understanding of the impact of the environment on the human personality. I had a friend when I was in high school who was a twin, and he was separated at birth. His mother was an alcoholic, and she didn't take care of either one of them. She adopted both of the individuals out, and he was adopted by a family that lived down the road from me. So he was an interesting friend. I like to go to his house because at my house we didn't have any pop, and he always had pop at his house. So, you know, if you wanted a Pepsi, go to Eddie's house. Turned out bad, but both of them turned out bad. As interesting as that is, they were adopted out fairly close to each other, but they never saw each other until later on in life. Both of them had drug problems, as curious as that is. Neither heredity nor the environment work separately to come up with a final human product. The reaction range of an individual is a combination of the environmental factors and hereditary traits to come up with a final human product. For example, when discussing height, an individual may have a height reaction range between 6 feet and 7 feet. With optimum food and exercise, a child may reach a height of 7 feet. Without it, he will end up somewhere in between. However, there are some hereditary traits that can rarely be changed by the environment, such as eye color, and this is known as canalization. In other words, you don't have a choice. If your eyes are blue when you're born, they're always going to be blue. There's no way around it. They will never change. Or brown, I guess you can put in. Well, but you haven't changed your eye color. All you do is change the way your eyes look. Genotype environment interaction refers to the interaction between the same environment on individuals with different genetic makeup. The classic example is looking at allergens in an area and seeing which children become allergic to them. A good example is my sister was very, very sensitive to poison ivy, but the other 5 of us weren't. So there you go. It also refers to individuals with similar genetic makeup growing up in different environments. The classic example is a child who has trouble in one family environment but thrives in another. This is a Big Bang Theory clip from a Big Bang Theory, if I can make it click. And I can't. There it goes. Okay, here we go.
Here's your tea, Mother.
Oolong?
Yes.
Loose, not bagged?
Yes.
Steeped 3 minutes?
Yes.
2% milk?
Yes.
Warmed separately?
Yes.
1 teaspoon sugar?
Yes.
Raw sugar?
Yes.
It's cold.
I'll start again.
I have the same problem with him. My theory is that his lack of focus stems from an overdeveloped sex drive.
Oh, I don't know where he would have gotten that. Aside from a pro forma consummation of our marriage, his father and I only had intercourse for the purposes of reproduction.
That seems a fairly efficient arrangement.
Yes, we think so. We've both done papers on it. Mine from a neuroscientific point of view and his from an anthropological. Mine, of course, was the only one worth reading.
Of course. I would very much like to read about your sex life.
Well, it's all online, or you can order it from the Princeton University Press.
Here's your tea, Mother. So, what are you guys talking about?
The frequency with which your parents had intercourse.
Swell. If you're lucky, maybe she'll show you the PowerPoint presentation.
I'm sorry, it's on my other laptop.
So, Mother, what's new?
You'll have to be more specific.
All right, what's new with you?
Oh, well, I've been having some fascinating menopausal symptoms recently.
Maybe something less personal.
Oh, your Uncle Floyd died.
Oh my God, what happened?
His heart stopped beating. I have to urinate.
What a remarkable woman.
Yeah, I thought you guys might hit it off.
I envy you your childhood.
I hate to tell you, but the only warm memories I have of my childhood are of my Uncle Floyd.
But you're clearly misremembering. Your mother is brilliant, analytical, insightful, and I'm betting she never hit you with a Bible because you wouldn't eat your Brussels sprouts.
Sheldon, you don't give your mother enough credit. She's warm, she's loving, she doesn't glue electrodes to your head to measure your brainwaves while potty training.
You were lucky. Yeah, when I was a kid, if I wanted an EEG, I had to attach my own electrodes.
Well, we don't need to watch this. Okay, so there you go. That was fun. If I can make this thing work. There we go. Genotype environment correlation. When the environment reinforces genetic differences because they work in the same direction, it is known as genotype environment correlation. There are ways that this can happen. Passive correlations, parents that give the traits to their children, also tend to maintain an environment that encourages the development of that trait. An example would be a musical family. There would be instruments around all they would have pianos and guitars and whatnot around for the child to utilize, and of course, because they have the musical trait, they would become musical. And this is a passive correlation. Reactive or evocative correlations, children with different traits will get different reactions from their parents. If you have one child that is good in mathematics and another child that is a good soccer player, the parents would react to one child by taking them, by putting them in advanced classes, and they would take the other child to soccer camp and to soccer. They put them on soccer teams and whatnot, so that they would both evolve their gifts. Active correlations: as a child gets older and are allowed to select their own activities, they will gravitate toward activities that they have a genetic proclivity to perform well. My son was a fast runner, so as he got older, of course, he gravitated toward cross country and toward track. He's also a good soccer player, but he didn't play as much soccer as he did run. My daughter was the same way. She was a fast runner as well. So as she also gravitated toward sports where she could demonstrate her ability to run fast. Not surprisingly, children who grow up in the same family often have very different personalities, IQs, and interests. This is due to the fact that the children born at different times in families cannot have the same experiences. This is known as non-shared environmental effects. These include the differences between boys and girls. Boys in the American society tend to be raised differently. They wear different clothes than a girl is. Composition of the family, it depends on how many children are in the family. If there were only 2 children in the family, of course, then that would be different. There were 6 in my family, and because there were 6, of course, sometimes we got lost. The historical impact of what is going on in the family. When I was born, we didn't have very much money. My dad didn't have very much. He wasn't as advanced as he was later on. He became vice president of the bank later on, and he made more money, and so we had more things that we could purchase. The food that we purchased was better later on in life. So it really all depends. So if my oldest sister, potentially she didn't have nearly as much as my youngest brother, who was kind of spoiled because he got just about whatever he wanted. The rest of us, one Christmas present, that was about it. He got all the clothes that he wanted. When I was growing up, of course, there were so many of us that they limited the amount of clothes that we bought for school every year. But as we got older, he could buy whatever clothes he wanted. Geneticists feel that similarities between siblings is probably due to genes, while differences are due to non-shared environmental factors. An example of IQs, the differences between the IQs in my family, among the 6 of us, was 30 points, which is a lot if you think about it. I think we're going to talk about this in a minute. Well, anyway, I'll talk about it again. Physical attributes: height, weight, intelligence, general intelligence, and specific abilities are influenced by genes. Enriched or impoverished environments will make or break a proclivity, but native intelligence levels tend to be closer to biological parents than adoptive parents. And of course, we had an enriched environment. My parents bought lots of magazines. We got to see lots of magazines. National Geographic was one of my favorites. We got a weekly news magazine. We got the Saturday Evening Post. We had a set of encyclopedias, so if we saw something on television, we could run to the encyclopedias and look it up. Whereas people, if they didn't have a set of encyclopedias, we had an enriched environment. If they didn't have a set of encyclopedias, they would see something they didn't understand. They would have to wait until they could get to a library to be able to look it up, or they just forget it. And of course, they wouldn't learn that single aspect. Personality studies of 5 major groupings of personality traits shows that there's a heritability of about 40%. Extroversion, neuroticism, being overly anxious, conscientiousness, agreeableness, and openness to experience. I have an aunt who had a lot of neuroticism. She was overly anxious, and she had 4 children, and all 4 of her children are exactly the same way. They're just extremely cautious, whereas we used to, jump off the roof and all kinds of crazy stuff. They would never do anything that might potentially hurt them because their mother taught them not to. They were neurotic. Select studies have shown that other personality traits may be influenced more by heredity than environment, temperament, activity, sociability, emotionality, shyness, and its antithesis, boldness. Psychopathology, there seems to be a strong genetic influence on at least 2 forms of psychopathology. Schizophrenia, loss of contact with reality marked by episodes of delusions and hallucinations. The risk of developing schizophrenia is 10 times greater among siblings and offspring of people suffering from schizophrenia than in the general population, with an estimated genetic contribution between 63% and 85%. Autism is a disorder marked by an inability to have normal social interaction. The individual has impaired communication and imagination. Children suffering from autism often develop obsessive ritualized routines and may display a repetitive movements that can be destructive to the individual. Gestation for, okay, so those are the 2 psychopathologies that we're pretty sure are inherited: schizophrenia and autism. And as it turns out, we have discovered by looking at the genes of individuals suffering from these that the schizophrenia and autism are on the same gene. Gestation for humans averages about 266 days or 9 months. Gestation is the length of time from fertilization to the emergence of the offspring from the womb. Prenatal development takes place in 3 stages. In the germinal stage, the growing structure is called a zygote. Zygote is Greek for yolk, because the structure, the individual is living off of the yolk during the germinal stage. The next stage is the embryonic stage, and the growing structure becomes an embryo. Embryo means egg. The stage before birth is the fetal stage, and the growing structure becomes a fetus. So it goes from a zygote to an embryo to a fetus. As the human grows from a zygote to a child, they develop in 2 different directions. Cephalocaudally, from the head down. The head is the first thing to develop, and then the rest of the body develops. And proximodistally, near to far. So they start developing from the torso, and then they develop out the legs and the arms and whatnot. And of course, this is the development of a child. This is what they look like. Wait a minute. Let me see if I can get my arrow back. There it is. Okay. There you go. This is what they look like right at. This is when they're a zygote. There they are. They're still a zygote here. Now they're an embryo. This is the embryonic stage, and this is the fetal stage. As you can see, they look. You can tell what they are. You can kind of tell what they are right here, but you can certainly tell what they are when they're a fetus. The terminal stage lasts from fertilization to about 2 weeks. The structure is known as a zygote. At 36-hour mark, the zygote begins rapid cell division through mitosis. By the 72-hour mark, 3 days, the zygote is 16 to 32 cells. At this point, the zygote is making its way down the fallopian tube to the uterus. By the 4th day, hopefully the zygote is floating free in the uterus. If the zygote gets stuck in the fallopian tube, it will grow until it is too big for the fallopian tube, and it will cause the fallopian tube to rupture. This condition is known as an ectopic pregnancy. It's extremely painful. There's also a lot of bleeding involved with it. Women have been known to bleed to death from an ectopic pregnancy that is not controlled. What has to happen is they need to go in and remove the pregnancy before it blows out the fallopian tube. As I told you, I had a girlfriend once who had an ectopic pregnancy, and she lost that fallopian tube, and she was afraid. After that, she was afraid to get pregnant because she was afraid she'd lose her other fallopian tube. Select cells will develop into the structures that will protect and feed the developing embryo. The placenta is the protective sac, the umbilical cord through which the embryo will be delivered oxygen and nourishment. And the amniotic sac is a fluid-filled membrane that protects the developing fetus. Chorion is the outer membrane of the amniotic sac. The trophoblast is the outer layer of the blastocyst that produces thread-like structures that penetrate the lining of the uterine wall, attaching and allowing it to tie into the mother's circulatory system. So once the zygote attaches itself to the uterine wall, now it is sharing blood with the mother. So whatever the mother uses, the baby uses. And this is what it looks like, all of those structures. There's the baby. This is at the very beginning, the blastocysts. This is the blastocyst attaching itself to the uterine wall. It is estimated that only 10 to 20% of fertilized eggs ever implant on the uterine wall. This task must take place before the 8 to 10 day of gestation, or the zygote's chances of survival decline rapidly. The embryonic stage runs from the 2 to 8 week gestation period. During this stage, the developing child becomes an embryo. The organs in the major body systems develop rapidly during this period. This is still in the first trimester. This is one of the reasons why you should make sure that you're not doing anything that you shouldn't do, using drugs, drinking alcohol, smoking tobacco, smoking marijuana, because it can actually change the structure of the fetus, of the embryo. The organs in the major body systems develop rapidly during this period. The embryo is quite vulnerable to destructive influences. Nervous system develops between the 2nd and 5th week. The heart develops between the 3.5 and 6.5 week mark. Arms develop between the 4.5 week to 8 week mark. The eyes develop at 4.5 to 8.5 weeks. Legs develop 4.5 to 8 weeks. Teeth develop 7 to 9 weeks. The palate develops 7 to 11 weeks. The external genitalia develops between the 7.5 and 11 week mark, and the ears develop at 4.5 to 9.5 weeks. So if she does something that is potentially destructive to the embryo at this stage, then something may potentially not develop properly. Unless an embryo is perfect, it will probably not survive the first trimester. If this is the case, an embryo will be spontaneously aborted or miscarried. A lot of times, the mother isn't even aware. Look, the nervous system is developing at 2 to 5 weeks. She may not even think about the fact that she's pregnant until she's late, and that's about at 2 weeks. So she may not even know she's pregnant for a long time. Eventually, until she starts gaining weight, she doesn't even think about it. Oh, good, I missed my period this time. At least I didn't have to put up with that. Sometimes she will have there will be a minor bit of bleeding, and she may think that is her period, and she's pregnant. She doesn't realize it until she misses her second period. And that's like 8 weeks. So by this time, the baby, as you can see, is completely developed. And of course, if she hasn't been a good girl and she's been drinking and smoking and or shooting up with something, now she's got a problem. Unless the embryo is perfect, of course, we talked about miscarriages. Between 50 and 70% of miscarriages are due to chromosomal abnormalities. More miscarriages occur to male embryos than female embryos. Why is that? It's because of that X chromosome. That X chromosome does not cancel out any problems that are. The Y chromosome doesn't cancel out any of the problems that may be on the X chromosome. And if that is the case, then of course the fetus will, or the embryo will be miscarried. 56% of all conceptions are male, but only 51% of all births are male, and that's because most of this 5% difference is they have a problem, and they will be aborted before they are born. At the eighth week or the second month mark, the developing child passes into the fetal stage and becomes a fetus. This stage is marked by the first development of bone cells. During the fetal stage, the growth rate of the fetus accelerates rapidly. The fetus marks the beginning of movement or quickening. Movement and fetal growth are normally monitored through ultrasounds. Males will differentiate themselves as early as in the 8th week, as they will be more active than females. My mother was something of a tomboy. When she got pregnant, she was 28 years old when she got pregnant with my sister. She thought there was something wrong with the baby because the baby never moved. Of course, she was very active, so she was real surprised that the baby didn't move very much. She was afraid that the baby would be born stillborn. But of course, my sister came out okay without any problems at all. And strangely enough, my sister hardly ever moved. She was lazy is not really the right word. She was just sedentary. She read a lot. She sat a lot. She didn't play any sports. She never came outside. She hardly ever walked. I mean, she was kind of sedentary. Let's just call her sedentary. And in the end, it really she died of cancer. And potentially, if she had been a little bit more active, she could have kept from developing cancer. But she was always the one that she was the pale one. She was, and I had 3 brothers and a sister, and everybody else was pretty active. And, we're always outside, and she was always inside reading or something. As weird as that is. Here we are, the baby's in the fetal stage. This is the beginning of the fetal stage, 8th to 13th week. This is the little girl. She has no penis. Beginning at about the 12th week, a fetus will begin swallowing its own amniotic fluid. Amniotic fluid is the waste products of the fetus. Amniocentesis is what I was trying to think of. Amniocentesis is where they draw some of the amniotic fluid out. They take a long needle and they stick it into the placenta, and they draw out some amniotic fluid. The swallowing stimulates the fetus's sense of smell and taste. By the 14th week, mature taste cells have appeared. If the mother has ingested a food or flavoring that crosses a placental barrier, the fetus will be tasting it over and over again. Alcohol is one of the chemicals that readily crosses a placental barrier. Some people, if their mother drank during pregnancy, some individuals will tell you that the first time they tasted alcohol, they liked the flavor. Potentially, I hate the taste of alcohol. I can't understand why anybody would drink it. But if they ate a select food, Italian food or Mexican food, that's why they develop a taste for those foods potentially. When my kids or when my wife was pregnant with my children, she used to eat cherry peppers, which are kind of hot. And both kids have they like olives and dill pickles and whatnot. And that may come from the fact that my wife ate so much of that stuff while she was pregnant. There we go. Okay, it's growing. It's growing. She's changing. The mother's changing, and the baby is growing. There we go. It's ready to come out. 9 months. It's ready to come out. There we go. First month. And watch her breast and how they change while she's pregnant. Some women can tell that they're pregnant by the fact that their breasts change. Watch her breast. There we go. See, it's getting larger. The areola is getting, the nipple is getting larger. And like I said, some women, before she even takes a pregnancy test, she knows she's pregnant because of her breasts have changed. If they've had, a couple of kids, they may be aware of that. The study of chemicals or substances that might affect a developing child is very complex. The mother is exposed to a chemical or substance during a critical period of development. When a select organ is being formed, the dangerous chemical or teratogen may cause irreparable damage. Any other time and exposure will do very little or no harm. And this is one of the reasons why anytime you take a medication, you have to ask your doctor. If you're pregnant, you need to talk to your doctor about it, because he knows whether this chemical is potentially dangerous for the child. That's one of the reasons why you need to check with your doctor before you take any drugs. One of the most critical aspects of pregnancy is the need to increase calorie intake, especially protein. It is estimated that women need to increase calorie intake by 300 to 500 calories a day. Women who gain between 22 and 46 pounds during pregnancy are less likely to miscarry or have low birth weight babies. Research shows that malnutrition during fetal growth can have lasting effects on the offspring. Dutch studies showed that prenatal nutritional deficiency in the second and third trimester resulted in increased antisocial personality disorder. And this was a study done during right after World War II. The Germans, the Allies tried to liberate the Netherlands, and they failed. So the Germans really cracked down on the Dutch because the Dutch were helping the Allies. So they took all their food away from them, and it was a time of starvation. And women who were pregnant during that time, of course, there were a lot of them. Women who were pregnant at that time, they were able to watch the people as they matured later on. The placenta tends to protect the developing fetus from select poisons that the mother might ingest or come in contact with. However, there are some chemicals and medications that do cross the placental barrier. One of them is tetracycline, which is an antibiotic. Accutane is actually heavy-duty tetracycline. It's an antibiotic for severe acne. Accutane, they used to use it in Vietnam. They used it as a prophylactic for gonorrhea. So they thought if they took Accutane, they'd never develop gonorrhea, which was kind of true. It was relatively rare. So we had a lot of people with acne in Vietnam. Barbiturates, of course, opiates cross the placental barrier, central nervous system depressants, non-steroidal anti-inflammatory drugs such as aspirin, NSAIDs, and hormones, of course. So the mother should never take her birth control pills while she's pregnant. Drugs that cross the placental barrier, diazepam, when taken during the last trimester, can cause irritability and exaggerated reflexes in the baby. Chloramphenicol is an antibiotic. It causes gray baby syndrome. With the baby, their circulation is poor. Cipro or Naroxen causes joint abnormalities. This is a antibiotic as well. Kanamycin crosses the placental barrier, causes deafness. This is an antibiotic. Macrodantin is another antibiotic. It causes anemia. Streptomycin, of course, is another antibiotic, causes deafness. Sulfonamides, we've already talked about the sulfa drugs. Taken late in pregnancy can cause jaundice and bleeding can cause jaundice. Coumadin is a blood thinner. it can cause bleeding problems. Carbamazepine, phenobarbital, and phenytoin these are anticonvulsants for epilepsy. They can cause birth defects. ACE inhibitors, of course, are blood pressure medications. Late in pregnancy, they can damage the fetus's kidneys. Beta blockers, another blood pressure medication, causes slowed growth due to low heart rate and sugar. Lithium is for bipolar disorder, is a medication that we give individuals with bipolar disorder. Can cause heart defects. Aspirin, ibuprofen, or naproxen, which is Aleve, can cause delayed labor, bleeding problems, heart problems, and jaundice. Chlorpromamide and tolbutamide will lower the blood sugar and cause birth defects. This is what we give individuals with type 2 diabetes to make them more sensitive to insulin. And what does this tell you? This tells you that women who have bipolar disorder have to go off their medication. Individuals who have a clotting problem have to go off their medication. Individuals who are epileptic have to go off their medication. You can't take any. The only thing you can take is acetaminophen as a painkiller. And people with type 2 diabetes shouldn't get pregnant because they'll have to go off their medication. And the rest of these are antibiotics. So people with blood pressure problems shouldn't get pregnant. People with type 2 diabetes probably shouldn't get pregnant. People who are epileptic shouldn't get pregnant. And people with blood clots shouldn't get pregnant. Physicians have discovered the effects of some drugs produce some fairly tragic results. Thalidomide was a drug given to women around the world in the 1950s to alleviate the symptoms of morning sickness, and it caused stunted and missing limbs. This lady has no arms. Severe facial deformities, defective organs, and it had this effect on about 12,000 babies. And here's a little girl with stunted arms, as you can see. Another surprise to physicians was the synthetic hormone diethylstilbestrol, or DES. It was introduced in the late 40s and early 50s to prevent miscarriages. My mother-in-law had this problem, and she took DES, and not with her first child, but with my wife and her brother. So this is a problem. Unfortunately, as the daughters of the mothers who took DES reached puberty, some developed rare forms of vaginal and cervical cancer, and for that reason, when my wife went in for her pap smear, they had to do a special pap smear for her because she was a DES baby. Some had a hard time maintaining their pregnancies. Some sons of DES mothers developed testicular cancer, and some were sterile. My brother-in-law does have a biological child that he produced, so he's okay. But my wife chose never to get pregnant because of her DES status. Since the 1980s, physicians have realized that women who consume alcohol throughout their pregnancy risk causing serious damage to their unborn infant. 1 out of every 750 infants born are born with fetal alcohol syndrome. Alcohol affects the fetal brain, changing the structure of the corpus callosum, which affects voluntary movement and higher order processing. 1 in every 75 births is born to a woman who drank moderately, a condition known as fetal alcohol effect. Fetal alcohol effect causes retarded growth, mild intellectual deficits, and delayed emotional development. And it is part of the problem is corpus callosum. We're going to see a picture of it in just a second. FAS causes slow prenatal and postnatal growth, facial and bodily malformations, disorders of the central nervous system, poor sucking responses, brain wave abnormalities, sleep disturbances, slow information processing, short attention span, restlessness, irritability, hyperactivity, learning disability, retarded growth, and motor impairments. This is one of the first babies that was discovered with fetal alcohol syndrome. Not exactly sure what they diagnosed him with before. As you can see, he has had an open heart surgery because of the malformation of his heart. This individual has a malformed facial structure, and of course, he has no cilium. This fold in between, right under the nose. These are individuals suffering from fetal alcohol syndrome. These are individuals from Germany, as weird as that is. And these are some more from Germany. The brain regions are affected by fetal alcohol syndrome. Corpus callosum, the cerebral cortex, isn't as involved, and the hippocampus and cerebellum are undersized. This is a baby. This is an individual. This is a normal corpus callosum. This is what a normal brain looks like. This is somebody with fetal alcohol syndrome. As you can see, the corpus callosum in this individual is almost not there at all. And as you can see, the cerebellum is also undersized in all of these individuals as well. And you can see how much convolutions there are in this child's brain, and how there are much fewer convolutions in this individual. The trend in the last 20 years is for men and women to wait longer to marry, and for women to delay reproduction until they are in their 30s. Recent research has disclosed that women who do not begin reproduction before the age of 28 are in a greater danger of having chromosomal damage to their ova and greater complications during pregnancies. The possibility of Down syndrome increases markedly with age and is especially prevalent in women over 40. When my daughter got pregnant, she was 42 years old. She gave birth at 43. We were both aware of the potential problems that she might have. So she's a biologist and I'm a psychologist. So we were watching her during her pregnancy. She passed the 22-week mark, and we're both celebrating. And of course, the baby was born without any problems at all. She was a really good girl. She made sure that all of she did everything correctly. She stopped drinking caffeine. She certainly stopped drinking alcohol. She never smoked. She exercised regularly. She really took care of that baby. To ensure the fetus gets adequate vitamins or the fetus doesn't deplete the mother's stores, the mother should supplement her diet with a multivitamin. 3 items that are essential to good fetal health are iodine, zinc, and the B vitamin, folic acid, or B9. Iodine prevents cretinism and thyroid problems. Zinc promotes cranial growth and proper weight gain. Folic acid, especially in the first days of fetal development, prevents neural tube defects such as anencephaly and spina bifida. Obese women have a higher risk of giving birth to babies with neural tube defects. They also tend to have greater complications during pregnancy, including miscarriage, stillbirth, neonatal death during the first month of life. Underweight women are more likely to have dangerously small babies. Moderate exercise does not seem to endanger the fetuses or of healthy women. In fact, regular exercise can prevent constipation and improve respiration, circulation, muscle tone, and skin elasticity, which will make for an easier delivery and quicker recovery postpartum. It is estimated that nicotine use by pregnant women causes 115,000 miscarriages every year in the United States. Nicotine has been identified as a contributing factor in 5,600 infant deaths a year. 53,000 babies are born underweight every year due to nicotine consumption. Infants of mothers who smoke have higher incidences of respiratory problems, including more colds and asthma. Excuse me. Evidence seems to indicate that smoking during pregnancy can cause poor attention span, hyperactivity, anxiety, learning and behavior problems, perceptual, motor, and linguistic problems, low IQ scores, low grade placement, and neurological problems. There is no definitive research to indicate that caffeine causes low birth weight, premature birth, retarded fetal growth, or miscarriage. However, moderate to heavy use, 4 or more cups of coffee a day, may increase the risk of sudden infant death and possibly spontaneous abortion. Marijuana has been shown to cause ovulation abnormalities in women and lower testosterone and sperm counts in men. Pregnant women have higher rates of spontaneous abortion, pregnancy complications, and delivery problems. Marijuana has been linked to a condition known as deranged immune cell factor leading to childhood cancer. There are higher rates of low birth weight in infants of marijuana smokers and may have such neurological disturbances as tremors and heightened startle response. Women who use opiates during pregnancy will probably give birth to a baby addicted to the drug. These babies are restless, irritable, have tremors, convulsions, fever, vomiting, breathing difficulties. If these babies survive, they cry often and show severe withdrawal symptoms. If they survive, they will always show developmental delays. This happened to my great-great nephew. My great niece was a heroin addict, and she got pregnant, and she refused to stop using during her pregnancy, and the baby was born addicted. He survived. They took him away from her, of course, because she was that irresponsible. And I'm not exactly sure how he's doing. That part of the family kind of stays isolated. They don't want. They're too embarrassed by what's going on in the family. Okay. Cocaine use during pregnancy can cause higher risks of a spontaneous abortion, prematurity, low birth weight, small head size. If the babies survive, they may be less alert, not responsive either emotionally or cognitively, congenitally, more excitable, more irritable, and with less able to regulate their sleep patterns. As they grow out of infancy, their lethargy, irritability, and unresponsiveness may prevent the infant from forming a close relationship with their mothers, who may have other problems as well. The cocaine-addicted child may be marked by excessive activity, muscular tension, exaggerated startle response, tremors, and evident antisocial behavior. As the individual gets older, their neurological problems will most likely improve, but their antisocial behavior probably will not. Once upon a time, I was teaching junior high school in Oklahoma City. The first crack baby in Oklahoma City was in my class. One day he came to the class during my planning period, and he knocked on the door. I opened the door, and he stuck a pistol in my chest and pulled the trigger. Luckily for me, the gun jammed and didn't fire. I was his favorite teacher. Why he tried to kill me, I'm not exactly sure. A teacher came by, saw what was going on, and yanked the gun out of his hand. He was antisocial personality, smiling through the whole thing, as weird as that sounds. Anyway, STIs tend to have different impacts on developing fetuses and newborns because of their structure and ability to cross a placental barrier. Gonorrhea, commonly called the clap, is a bacteria that will not cross the placental barrier, but can do a great deal of scarring to the reproductive organs of both males and females. In females, scarring in the fallopian tube may be so extensive that the zygote is not able to migrate down the tubes to the uterus, or the tubes may be blocked completely. In males, scarring can cause impeded sperm flow through the vas deferens to the point of blockage and sterility. And I had a lab officer when I was in the service who had contracted gonorrhea a dozen times when he was in Vietnam. and he was sterile, and the reason he was sterile was because of all the blockage. It blocked different areas of his urethra, which made it impossible for some of the fluid, the alkaline fluid, to get out, and his semen was not alkaline enough to neutralize the acidic reproductive area of his wife. Since gonorrhea is often asymptomatic in women, it is possible for women to deliver when she is infected with gonorrhea. If the baby passes through the birth canal when the mother is infected with gonorrhea, the baby may become infected as well. The most serious danger, of course, is an infection of the eyes, which will cause blindness. For this reason, silver nitrate is placed in the baby's eyes after delivery. Other problems that might affect a baby include heart infections, lung infections, and joint infections. The syphilis bacteria, Treponema pallidum, is able to cross the placental barrier. If the fetus is infected, it may result in premature delivery, stillbirth, or congenital syphilis. Genital herpes is a virus that, if present during delivery, can cause blindness and even death. We used to check every baby for syphilis when I was in the service, and we only found one. Of thousands of births, we only found one that had congenital syphilis. AIDS caused by the HIV or HTLV3 viruses disrupts the body's immune function. The virus can cross the placental barrier but can be blocked if select antiviral drugs are taken by the mother during pregnancy. Unfortunately, these drugs are relatively expensive and therefore rarely available in Africa, where the disease continues to devastate the continent. Babies born with the AIDS virus may develop a full-blown disease at any time. Some develop antibodies that destroy the virus before it is allowed to replicate. Despite all the programs in place to assist pregnant women, universal prenatal care still does not always take place. While the national average for women who get late or no prenatal care for all races is 3.9%, for natives, the figure is an abysmal 8.6%. Other minorities are also above the national average, including blacks, Mexican Americans, Puerto Ricans, Hawaiians, and Central and South Americans. Up until 21 weeks, 0% survival rate for babies. 22 weeks, the survival rate is around 10%. 23 weeks, 10 to 35% survival rate. 24 weeks, 40 to 70% survival rate. 25 weeks, 50 to 80% survival rate. 26 weeks, 80 to 90% survival rate. 27 weeks, greater than 90% survival rate. The youngest baby to ever survive was born just under 20 weeks. And this is something to think about. So if you can get in the middle, 23, 24, 25 week mark, you're good to go. Probability is that the baby will survive. The first stage of delivery is the longest and typically lasts 12 hours or more. In first children, the first stage is longer and becomes exceedingly shorter the more children a woman has. This stage involves contractions of the uterus, causing the tiny hole in the cervix to expand enough to allow the bulk of the baby to pass through. My sister-in-law, her first child, she was in labor for about 14 hours. Her second child, she was in labor for 8 hours. Her last child, she was in labor for less than 2 hours. She gave birth in the taxi cab, in the parking lot of the hospital. The second stage of labor typically takes 1.5 hours or less. This stage begins when the baby's head begins to move through the cervix and into the vaginal canal. The stage ends when the baby completely emerges from the mother's body. If this stage lasts longer than 2 hours, the physician may use some form of assistance to extract the infant. The third stage lasts 5 to 30 minutes and involves the placenta and the umbilical cord being expelled from the mother's body. Was previously called passing the afterbirth, but names have been changed to protect the delicacy of people's feelings. The fourth stage involves a recovery process where the baby and the mother both rest and their condition is monitored. Cesarean delivery is a surgical procedure to remove the baby from the uterus by cutting through the abdomen. Cesarean birth rates in the United States are among the highest in the world. The country with the highest cesarean birth rate is actually Brazil. And, well, they're the ones that developed this cut right here. This is known as a bikini cut. If you cut this way, it's from the umbilicus all the way down to the pubic bone. It's a little bit easier to get them out this way, the vertical incision. But this, of course, hides the incision under your bikini bottom. So this is more popular. My daughter had a cesarean section, and she had the horizontal incision. My first wife had two vertical incisions, and she's got a scar running from her umbilicus to her pubic bone. Alternative methods of childbirth minimize the use of drugs while maximizing parents' active involvement. Complications of childbirth. Birth trauma may be caused by anoxia, which is oxygen deprivation, diseases, infections, or physical injury. Low birth weight babies fall in two categories: preterm and small for date. A low birth weight baby, if necessary, is placed in an antiseptic temperature-controlled crib known as an incubator and fed through tubes. PKU, 50 years ago, the leading cause of intellectual disability in the United States was a condition in some neonates that did not allow them to metabolize protein properly. This condition caused a buildup of phenylketonuria, which is a waste product in the blood, which destroyed brain cells. Now, by screening all babies at birth, phenylketonurics can be placed on a special diet and live otherwise normal lives. Hypothyroidism and galactosemia, also known as maple syrup disease, are also screened at birth in most states. This is the infant mortality rate. As you can see, the United States is way down here. Iceland is best, Japan, Sweden, Norway. There you go. As weird as that seems, we're way down the list. The highest infant mortality rates are almost all African countries. Are all African countries except for Afghanistan. Yeah. The lowest birth weight are almost all European countries. They're also the developed countries in Southern Asia, South Korea, Singapore, Hong Kong, and where's Japan? There's Japan right there. Okay, there you go. And that is the end. And I've been talking too long, so I will end this thing right here.